Okay, here we have these two bearings. The original Fadal thrust bearing is a 7304B, and this is the Chinese thrust bearing that's designed for a ball screw. So they're both 20 by 52 by 15. So that's zeroed pretty close. The supposed only difference is that these are 60 degree or 61 degree contact angle, and these are 45 degree contact angle. And there's obviously some other cosmetic, well, not just cosmetic. This one has a brass. This is a plastic ball cage. So this has a lot of, well, a lot more than the other one play in the between where they actuate. This is a little tighter filling at that. I mean, they're not supposed to be tight, obviously, because they're thrust bearings that you need a set back to back. This is the packaging that the Chinese, the part number for the Chinese one is 7603040CSUP4. Let's go ahead and measure some of these dimensions. Okay. So our ID just look like 20 millimeters. OD 15. It's not very important. Well, that wasn't OD. That was width. The OD is that's as accurate as that's accurate enough. 51.9. Yeah, we had a 99 there too. So it's 52 there. Yeah, it's 52. Close, same as this NSK Japan brand. One thing I do like about these is that they're marked, because they're actual thrust bearings. I don't know if you can see that, but it's marked with the V shape, the direction that they would go towards each other. And there's even some little circular O marks on here. I'm not sure if what that exactly signifies. These are not greased is one difference. The NSK ones came greased. So I gotta fill these with some, I was gonna use electric motor grease is what one of the bearing brands recommends for these kind of bearings. So let's go ahead and open another one. See what they feel like, just abutting each other. So if they're going to be abutting each other, they have a much wider flange. That is a difference, actually. These have a width, well, yeah, the ground part is definitely wider between the two. So the ground section on the Chinese thrust bearing is 0.48 millimeters. There's the ground section on 45 degree contact angle bearing is, so 3.52 to 4.8. So over a millimeter more contact area on this inner race, which I don't know if that really matters, but it's just a difference. So I would be putting them like this. Yeah. And then they're already touching, so they're, yeah, I mean, tolerance is reasonably good. I was wondering if they have a built-in preload. That's the only thing I wasn't sure on. If they're designed to be shimmed, which these you have to shim because they're designed with no preload. And they're not, you can't buy a matched set of these bearings, these 7304Bs. But these, I don't have matched sets, but they are probably ground to have a preload without a shim. Let me get another one. So the bearings did come with these little certification cards with the part number and saying that they were made in 2019-212. And then some, I'm not sure what this is, specifications. Maybe I'll try to translate that later. So I figured someone might want to see this thing disassembled. This is the X bearing housing for my 4020 Fadal. And these screws clamp the two thrust bearings together. Maybe that's a little better lighting. Probably not the best way to do it. I don't know. So you can see with this bearing, there's this little, which I believe is a 1,000th, really thin shim. And this shim came with the original set that was on here in the machine. I ordered some new shims, but they aren't here yet. So I attempted to reuse this one. But I ended up with the same backlash in these bearings, which is 3/10,000ths of an inch, no matter, I mean, and I could have preloaded it more with more shims. That's probably the only way to get more preload. But in the meantime, I read on some forums that, on the one of the CNC machining forums, I'll provide a link to that, that these bearings are just not really designed for this. They're not designed to be thrust bearings in a CNC machine. You should have actual 60 instead of 45-degree contact angle, which is the contact angle between the balls and the two raceways. It's hard for me to explain without a diagram, but these ones have a 60-degree contact angle, which I believe that the angle, instead of being 45 like this, you know, and if the bearing is like this, so if the bearing's like this, the 45 degrees would be, you know, 45 degrees to that, whereas 60 degrees, I believe, is like this direction is where the 60 degrees go. So instead of getting, you know, an equal amount of thrust in axial and I don't know what the right term for it is, but instead of pushing outward, you know, into the races or else into the shaft direction, you have more support on the shaft directions with the 60-degree angle. So that's what these new ones, these new actual thrust bearings have, is 60-degree contact angle. And we'll measure backlash and see how that compares. Probably need to use a press to get this in. Yeah, this side usually isn't just a drop-in fit, which is good. This retainer is it's a looser fit. So let's see how that's gonna go. Just look at where's the arrow? I know which way it's gonna go. Yeah, the arrow points to the middle, so you want the two arrows pointing to the middle to have the thrust correct. So yeah, this one's going to go in, looks like. It tends to get crooked easily, but I don't know what the best way to push things is without. There we go. That was it. Okay, so that one, it probably is the same tolerance that these has, because that's a very similar fill to the when I was putting in these new bearings last time. So I think the tolerance on the OD is good. I mean, just based on that, rough. Okay, we got a new plan. I don't know if it's the right plan, but it's a plan that we're gonna try. And that is to use this little brass hammer that I found. I did just clean it off with some WD-40. So Now that is some preload. Oh yeah. That's what we like to fill. So the problem with these, with 1000 spacer, the preload was nothing like this. It was not like stiff. It had some resistance, don't get me wrong, but wasn't much more than the grease was providing. Like my hand's just spinning in it now because it's pretty stiff. Oh, yeah, and it stops right away. It won't just freewheel. These are the oil seals. This 11138. There's a couple different manufacturers. So yeah, CRW 11138, but these are made by SKF. Hopefully, see they're yeah, SKF 11138. They're made in Mexico. Yeah, made in Mexico. Okay, going out to the 80-ton press. You guys be able to see from here. I'm really liking this magnetic little Joby tripod thing. Okay, so I know there's lots of metal shavings. We're gonna wipe off some of the metal shavings. Clean the press thing a little bit. Try this side first. I don't know. Actually, I'm gonna put a paper towel. Keep more of the dirt off this thing. And I just realized I am gonna need something to push against this. Yeah, okay. I don't know why I got started crooked, but it straightened out. Was that already too far?